make some remarks.
Yeah, welcome to the first regular session of this joint conference. And first talk will be by David Goldstein, David Haug, on second position clitics in ancient Greek.
Thank you very much. So there's photocopies of the slides are circulating. It looks like they've all gone around. So ancient Greek is famous for its rich stock of second position clitics, whose distributional patterns require reference to both prosodic and syntactic constituency, as illustrated by the following example. Is this not? Which reads, "For since this battle, the Athenian herald prays that good things befall the Athenians and Plataeans together when the Athenians conduct their sacrifices at the festivals that occur every 4 years." So in this example, we have two second position clitics, which are bold-faced and occur after the first prosodic word of the clause. These two clitics are gar and spi. Gar is a discourse particle that takes as an argument an entire sentence and means something like English for, and spi is a dative pronominal clitic. And in the the following two trees reveal a mismatch between prosodic constituency and syntactic constituency. So as you can see, the preposition apo, which means from, and that's the first word, and tautes, which is a determiner meaning something like this. Together, these two form a prosodic word, that is, they occur under the node, the omega node, and directly after this, we get our two second position clitics. Crucially, apo and tautes do not form a syntactic constituent. That is, the preposition and the determiner are not dominated by a single node. Now, this distributional pattern has been a source of constant challenges, both within LFG analyses, to say nothing of other frameworks. And the root of the problem is the ability of clitics to appear in surface positions where they cannot be assigned a grammatical function. So to deal with this, existing accounts of second position behavior either involve non-trivial departures from the core assumptions of LSG or simply have trouble with certain empirical patterns. These non-trivial departures from standard assumptions include the assumption of pipeline architecture, by which you're basically giving up on the assumption of non-derivational syntax, or non-standard constituents such as the clitic cluster, which is allowed to assign grammatical function, the use of optimality theory with cross-derivational comparison, or assuming a mismatch between C structure and either the P string or the S string. Or finally, the use of prosodic markers in syntax, which basically opens the door to empty categories. Now, crucial to this issue is the capacity of C structure and F structure. As many of you are aware, there are both formal and linguistic differences between these two levels of representation. So formally, C structure can only handle phenomena within the locality domain of a context-free grammar. That is, the one-level tree corresponding to a phrase structure rule, whereas F structure can handle phenomena at an unbounded distance. So what this amounts to is that C structures deal with word order and constituency, whereas F structures deal with more abstract syntactic relationships. And this translates into a claim that there are no non-local word order or constituency facts. But this is precisely what second position distribution of the type in ancient Greek seems to involve, that is, these non-local constituents. And on our view, this fact motivates a move to a richer C structure with an extended locality domain, which is more concretely a multiple context-free grammar, or a 2-MCFG. So in essence, what we're doing is modifying the division of labor between the C structure and the F structure so as to capture two crucial insights into the nature of second position clitic behavior in ancient Greek. So the role of syntax on our count is decidedly minimal compared to other models. All that matters is where the edges of large domains, such as the S constituent and the CP constituent, lie. And as prosodic constituency need not align with syntactic constituency, there is no dedicated C structure position for second position clitics. So just a quick word on where the data come from. The examples are drawn from Herodotus' Histories, which is a text that comes from the 5th century BC and is a corpus of just under 200,000 words. Now a quick outline of what we're going to do. In the next section I'll present some more data, and then Dag will introduce you to multiple context-free grammars, which will be followed by our analysis in more detail. And this we'll then use to draw a comparison with previous accounts in LFG, and finally we'll offer some summary remarks and look at future work. And 7 contains an appendix with some residual issues which we won't talk about but are on the photocopied slides. So turning now to a closer look at the data. As I mentioned, the clitics in ancient Greek are fairly famous, not only for their distributional patterns, but also because the clitic lexicon of ancient Greek is so large. It's larger than that of any other archaic Indo-European language. It encompasses personal pronouns, as we've already seen. It encompasses a few verb forms, conjunction, discourse particles, and modal particles. Now, a crucial observation, going back to Mark Hale's dissertation in the late 80s, is that while we talk about second position as though it were a unique entity, there is in fact no single second position in which all of these clitics occur. So we have to, and we think that this observation motivates a view that clitics subcategorize for particular syntactic and prosodic domains. In particular, we recognize the following 3 domains for the clitic lexicon in ancient Greek. There are sentence clitics. These are invariably discourse connectives, such as the example of gar that we've already seen, that mark intersentential relationships. And we assume that they have the category, that they are non-projecting adverbs. Just beneath that, the domain of causal clitics. These realize grammatical features of the clause. These can be non-projecting adverbs, Ds, such as the pronoun that we saw in the opening example, and verbs. Finally, phrasal clitics. These realize grammatical features of subclausal XPs, and we will have nothing to say about these here. I just want to point out 2 more features of these various classes. So when you have clitics from each domain in a clause, the order that they will follow is phrasal, sentential, and clausal. And we'll see an example of this very shortly. And you'll notice also in the table that there are clitics that can have variable scope domains. So these are the 2 clitics, de and men. We assume that they are sentence level clitics or sentential clitics because they can connect sentences, and they're also phrasal clitics because they appear on inside topicalized XPs. And we'll also see an example of this very shortly. Now, taken all together, ancient Greek displays a fairly complex array of clitic positioning patterns, so we have to narrow our focus for today's talk on the core generalizations, which are as follows. So by and large, clitic domains mirror clitic scope. So sentential clitics go in CP or second within CP, whereas clausal clitics belong to the S domain. So what this means is that whenever a projection above S, such as an adjoined topic phrase, is present, we'll get what we call splaying. That is where the sentential clitics are second within CP, and the clause domain clitics are second within S. Now, when there is no material outside the S constituent, sentential clitics directly precede the clausal ones. Crucially, clitics must have a prosodic host in their domain. Clausal clitics require a prosodic word, whereas sentential clitics can take either a morphosyntactic word, that is some sort of sub-prosodic word entity, or a prosodic word. So their host requirements are a little looser. And on the basis of secondary accentuation patterns, we assume that the combination of host plus enclitic invariably projects a recursive prosodic word. So in the following example, we see topicalization at work, which also illustrates splaying. So the example reads, for on the previous day, everything was bad for them. The constituent on the previous day is topicalized, and there you see the clitic men marking the topicalized phrase. That's an example of a phrasal clitic. Directly after that, we have the sentential clitic gar, and then preceding the topicalized noun phrase, we find panta and then spi. So that is the clitic pronoun spi is second within the s constituent. Altogether, this here we see the order phrasal, sentential, and clausal in men, gar, and svi. So turning to our next example. So this, we do not have anything, there is no material present in CP, so we do not find any splaying in this case, which reads, for the children from the village, while playing, chose me as their king. So here the sentence starts off, hoi, that's a definite article, gar, me. Gar is again the sentential clitic, and as there's nothing high enough to host it, it directly precedes the pronominal clitic me. This example is of interest because it also illustrates the ability of a sub-prosodic word to serve as the host of a sentential clitic. So hoi is assumed to be a proclitic, and the idea is that hoi and gar, so the idea is first that gar just wants some morphosyntactic element, and hoi will suffice for that purpose. And then hoi and gar together build a prosodic word that serves as the host of the pronominal clitic me. As if you'll recall, the clausal clitics care much more about the prosodic size of their hosts. Now in the next example, we see this host variability among the sentential clitics at work. The sentence reads, for I have thought that not each man is capable of such deeds, but blah, blah, blah. So here again, we have our sentential clitic gar. This time, however, it is not hosted by the first morphosyntactic word of the clause, but rather the combination of definite determiner ta and the noun or adjective toyauta, meaning such. And so this is the host variability that you see among sentential clitics. So putting all of this together, the clausal structure that we assume for ancient Greek looks as follows. There are two projections that are adjoined to CP, a sentential adverbial one at the very top, and then a topicalized phrase just beneath that. We assume that WH phrases occupy spec CP, and then adjoined to the S constituent is a focus projection. And finally, down below, we have the S constituent, which we assume, because Greek is a so-called free word order language, or ancient Greek is at least a free word order language. And the phrase structure rules that we assume are as follows. So we have three sets: clause level rules, adjunction to clausal categories, and lexical phrases. As these are all fairly standard, I won't go through them in detail. I do want to call your attention to the parts that are highlighted in red. So what's crucial to our account is that there are no special phrase structure rules that specifically target clitics. So in the S domain, anything can occur. Anything that satisfies that phrase structure rule can occur there. And likewise, with the adjunction to clausal categories, any adverb P can adjoin to CP. So these are, again, not clitic-specific phrase structure rules that we're setting up. And now with that, Dog is going to introduce you to multiple context-free grammar.
Okay. So, as David mentioned, we're going to use a slightly richer form of C structure than is normally assumed in LFG. So I'll say something about that first before we get to the analysis. If you think about standard context-free grammar, what happens is that a rule at the same time specifies how to form a category. Right? So for example, a DP goes to a D and an NP. So the D and the NP together makes up category DP. And it also tells you that the yield of the DP node is the concatenation of the yield of the D node and the NP node. So in a sense, you put together category formation and yield computation in a CFG rule. But in MCFG, you can dissociate those processes by having explicit yield functions telling you how to compute the yield of, for example, that rule. And that's what we're going to see. You can think of a CFG, ordinary CFG, as a special case of an MCFG where you only use concatenations, right? So the daughter nodes are always concatenated. But for our purposes, we will use slightly more complex yield functions to get discontinuous constituents. So here's an example. So first of all, this requires that we work with the possibility that yields are tuples, right? It can be string tuples rather than a string. So obviously at the highest level, at the CP level, we won't have a string. But intermediate nodes can have yields that are tuples of strings. So here is an example from a DP rule. So the DP goes to D and NP, and you compute the yield of the DP node from the D and the NP with the function S1, so this means split of the first constituent. So to explain the notation, so we need to talk about not just daughter nodes, but components of daughter nodes in case they have a complex yield. So this means the first component of the first daughter. So it's this, it's the string yield of D. And this means the first component of the second daughter. So it's this, right? The NP. So both daughters in this example are continuous. So they have a single string as a yield. But the yield of the DP node is complex. It's a tuple consisting of two strings. Right? And this is what the square brackets indicate. Right? So basically we have two parts. So this means that in this case, using this rule, the DP may be split by between the first and only component of the first argument and the first and only component of the second argument. So this is an idea similar to what you find in head grammars, where you have a distinguished word. So you have a headed string and you can split after that head. So that's the DP rule. Now, of course, once we introduce discontinuities like that, we need a way of passing them up the tree, and we need a way of resolving them. So here's how we do the propagation up the tree. Basically, if a daughter node is discontinuous, we can propagate that, but only one discontinuity. So this is to keep the complexity of the C structure down. So we can only have a single discontinuous daughter node, and we can propagate that discontinuity. So here is an example of the PP going to a P and a DP, and you compute the yield of the PP node with the function P2, so propagate in the second argument, second daughter, and you form that yield by taking then so as the first component, take the first component of the first daughter, so the P basically, and you concatenate it with the first part of the DP here. So this gives you one string, and then this gives you another string, which is the second part of the DP. So the PP is discontinuous at the point where its object DP is discontinuous. So again, this is similar to things you can do in head grammar. But it's important here for the complexity issues that you can't embed, so you can't increase. There will at every point only be a single discontinuous daughter. So finally, you can resolve discontinuities at the highest level. So here's an example with the S rule. So here's an S expanding in this case to a non-projecting V, which is a clitic, modal clitic, a PP, and a normal verb. And you compute the yield with the resolve by the second argument rule, so R sub 2. So what happens with this rule is that you wrap the second argument around the first. Right? And for this to work, the second argument, the second daughter needs to be discontinuous. So assuming we built the PP with the rules we already saw, you get a discontinuous second element, and you wrap that around the clitic V, right? Which is 1, 1. And again, this is a wrap operation familiar from head grammar. But crucially, we need to be able to do this also without resolving the discontinuity. So either you get this, where you have a single S, continuous S, or you leave the discontinuity open for the CP to put further clitics in. But at the top level, you will always need to resolve the discontinuity. So that's very quickly how it works. And we combine this with LFG by just having, so using MCFG rules instead of standard CFG rules, but everything else stays the same. So we have functional annotations on the rules. They work in the usual way. The only difference is we compute the yield, the C structure string, using the yield functions. And we assume this set of yield functions you saw, right? So you can split, propagate, host, and resolve, and concatenate, which is the default. And we can assume that yield functions combine freely with productions, so we don't have to specify which productions take which yield functions. It will work out on the assumption that only non-protecting words can break up the yield of another node. So that's a syntactic explanation. You could also think there could be a prosodic explanation, so we don't want to commit too much on that. So this actually does not alter the complexity of the LFG formalism. I won't go into the details here, but there are papers from the 90s by Seki and co-workers using MCFGs to define polynomial time possible LFG grammars and showing that you can translate back and forth between LFGs and MCFGs. So, but we can talk about it in the question period if you're interested. It does obviously increase the complexity of C structure parsing, so it will be done in quintic time rather than cubic time. Okay, so that's the MCFG part. Now we're going to adopt an analysis of the syntax-prosody interface, which is comes from Dalrymple and Mycock's analysis. So basically, we build syntactic and prosodic trees in tandem, and they simultaneously have to satisfy the relevant syntactic and prosodic constraints. The interaction is confined to the lexicon, where the terminals of the two trees meet, and the lexicon, so that's where the interaction happens, and lexicons can specify both syntactic constraints and prosodic ones. And we're going to handle host selection with a host feature at the chi structure, so the structure that has the interface information on the prosodic side. Okay, before we see some examples, we're going to talk about how we do the prosodic incorporation, which is what happens. So we assume on the basis of metrical data that there's always prosodic incorporation of the two. So we always have recursive prosodic words when you have a host and a clitic. But and there's evidence from this coming from secondary stress assignment, which can happen in two different ways. So either by an accent calculus, which we won't go into the details of. So that's one pattern. And the second pattern is the one where the clitic actually has a secondary stress, which is marked by a graphical accent. So here are examples of this. So in the case where there's so if the word is under a certain length, you get no stress, no secondary stress, right? So pantas phi just simply says this is pantas phi. There's no secondary stress, but you have a recursive prosodic word. but if the host and the clitic are longer, you can get this pattern where you get a secondary accent on the host here, right? So antropoi tinnes becomes antropoi tinnes. Get this secondary stress here. So that's the secondary stress pattern, calculus pattern, and then there's another pattern where you have a fixed secondary stress on the clitic, which you see with GAR. Here, and also, so these ones can combine with subprosodic words, the ones that have lexical accent. Okay, so we model this with some rules. So we jump to the next slide. The host and the clitic forms a recursive prosodic word through sigma adjunction. So basically we adjoin a syllable to the prosodic word. But crucially, this operation is only licensed at the left edge of an intonation phrase. So that's what you see here. And this marks the host as a prosodic word, right? So that's what goes on with these examples. And the same rule can also handle postpositives so the sentential clitics that can sometimes bear lexical accents. So the example we had with ta-ta-yaut-agar, where gar, despite having its own accent, combines with not the first morphosyntactic word, but with the first prosodic word, you get the same rule, and it's marked as having a prosodic word host. And finally, so yeah, this should be postpositives hosted by a subprosodic word. Right? So this can also happen. We assume, so here the details are a little less clear, but it is clear that the result is a prosodic word, again from metrical evidence. So we assume this happens through stray adjunction, so the syllables together form a prosodic word. And this can also is also only licensed at the left edge of an intonation phrase, and it marks the host as being a syllable rather than a prosodic word. So then we need to handle host selection in the lexical entries of the clitics. So they will look like this. So gar will be a non-projecting adverb marked as being happy with any host, right? It just says, I want a host. Whereas sentential clitics like me says, I want to have a prosodic word as a host, right? So that's the difference. So this one's happy to go after the first morphological word, but it can also wait until the first prosodic word. So with this in place, we can see some examples of how this will work. So these are the examples we saw early in the talk. So here's the splaying example. What happens here is that we build these trees. We combine. So in order to satisfy the prosodic constraints, we're allowed to use the yield functions, right? So basically, we create here. We split the DP after the first daughter, we propagate that up to CP, and then we resolve at the highest level. So this puts gar here for entirely prosodic reasons, right? So the only thing the syntax says is gar is introduced by adjunction to CP. That's the thing. But for prosodic reasons, it wants to go there, and that's what yield functions give us, and that gives us a well-formed prosodic tree here. Respecting the relevant prosodic constraints. And you see one advantage of this approach is that we're able to treat the other clitic, so the closer clitic here, as nothing special, right? It's just introduced as a second daughter, and because the first daughter is a constituent, which is exactly one prosodic word long, everything's fine and we don't need to assume anything special going on with this clitic. Okay, here's the pattern where you have no splaying. So in this case, we need to apply the hosting rule here. That does not. So this wraps the first daughter, the DP, around the D, the closer clitic me, but it leaves the hole in the DP, as it were, open, and is propagated up to the CP level, where you get the adjunction of the sentential clitic. And again, we get a well-formed prosodic tree. So what's interesting here is that Hoi alone would not be a listed host for me because it's not a prosodic word, but after the adjunction, so on prosodic side here, these two together form, so this clitic, this clitic attaching to this morphosyntactic word together protects a prosodic word that can then act as a host of me. Yeah. Okay, so we'll just be very quick about what this biases compared to other approaches. We can't really do justice to other approaches as they have been worked out, but the main difference here between other recent work is that we're not, well, everyone has to try to put the clitic in the right position with the C structure in it, so you get the right function, right? Everyone has to do that. And in recent work, this is done via some displacement, either between the S string and the C structure, or between the P string and the S string. But this actually creates the need to motivate the non-surface position in the C structure. And you need a way to enforce that. And typically that's enforced with special phrase rules targeting clitics, right? So you have a CL category, which we think are problematic, right? So because clitic chains are not syntactic constituents, there's no evidence for that. And clitic is a syntactic category whose defining property is prosodic. So those are problems with the CCL. Need to go quickly on that. But the more serious problem, I think, is that if you have some sort of displacement, you actually need to have some sort of underlying position. So how do we actually know where the clitic goes? So traditionally, the only criterion for where to put words in the C structure, like linearly, is where it surfaces, right? But if you have some sort of displacement, you need to motivate why me is here, right? That's the first order. And there's no reason, right? There's no, in Greek, given that Greek is non-configurational, there's no particular syntactic reason why me would want to go there in the first place. You may be able to argue that the sentential clitic, given its sentential scope, wants to adjoin to the highest node, but for a normal word pronoun like me, there's no particular reason why it should be first, but it has to be if you if you afterwards want to move it. And this is even clearer for cases where this actually surfaces as pantas phi, but you have to, on displacement approaches, you have to assume something like phi panta, which is the input to prosodic inversion, right? Whereas we're able to just treat it as nothing special. So those we think are advantages of this approach. Once we dissociate category formation and yield calculation, we don't need these syntactically motivated positions where you can actually never see the clitic. We only need the actually observed position, which is prosodically motivated. And then as far as syntax is concerned, the clitic can go wherever a maximal D protection can go, right? So non-projecting D goes wherever a DP goes. There's actually evidence from this from metrical text. So I don't think I can talk you through the example, but you can see clitics hosted at the left edge of a verse. And the assumption here is that the line, the start of the metrical line, forms an intonation phrase that can also host a clitic, right? Because this is licensed at the left edge of an intonation phrase. Okay, summing up. We don't say that the behavior of second position clitic is syntactically normal. We just say that syntax plays a very reduced role, right? So syntax basically only assign domains, right? So licit mother nodes. So what is special about second position clitics is that they're defective, they cannot show up everywhere, and most of this is prosodically motivated. There's some syntactic constraints as well that we did not talk about, like being able to be coordinated and so on. And this we're able to, without cross-derivational comparison and without relying on syntactic non-surface positions. Okay, thank you.
Good 10 minutes for questions.
I don't know if this holds for ancient Greek, but it does for the Slavic clitic cluster languages, where there does appear to be a syntactic order within the clitic cluster, and not because some appear to be intentional and some not. And I was curious how you capture that in this approach.
Yeah. You want to?
That's a very good question and really an open question. So the facts about the ordering between the domains hold very well, but this inside each domain, it's there are generalizations, but there is also a lot of variation. And this is actually, if we had more time, something that we would have mentioned as for future work, because we're just not sure if it's templatic or if you need to make reference to the prosodic shape of the clitic cluster, if this somehow plays a role. But yeah, this is an ongoing issue of research.
I'll keep it short. So I have two questions. One is when you're saying how do you know where the clitic was in the first place? Isn't the usual thing that you say where's the non-clitic version? Is the problem here that there is no non-clitic version? Or like where the DP would be in the case of me?
Yeah, so the problem is that it could be anywhere in S, right?
Okay.
The non-clitics. So for example, me has a stressed counterpart, a me, and it can go everywhere in S because
So then
Greek
you
is
just put it at
non-configurational.
some random position in S.
Yeah, but then you can't have it targeted. Yes, and then you can't have it targeted by prosodic inversion, right?
And then the other question I didn't quite understand is, so you have your syntactic tree and you have your prosodic tree. So how are you making those correspond to one another, or are they just in parallel and not talking to each other?
No, they're talking to each other in the same way as
Just
in
for
the
terminals.
Yeah.
And the follow-up question would be then, why not just have a mismatch? But I guess other people might ask that.
Yeah.
So.
Yeah.
So I have this list of things that you don't like about some of the other
Yeah.
solutions, like the pipeline architecture and so forth. But the pipeline architecture itself, for example, is just the representation of modularity. And if you think of it as a pipeline, you're thinking of it as a sequence of computations or something that are taking place. But really, what it is a composition of different components of different types that are all mutually satisfiable. So we already know, for example, that the morphology, to the extent that it can be represented by a regular relation, if the LFTs are closed under composition of the regular relation, and in the second position proposal, one of the other ones, it was just an observation that a very limited kind of reordering could be accomplished with that same regular relation composition. So it didn't have the formal power and was really very, very finitely bounded. And I think by going to the MCFGs, you're maybe opening the door to a wider variety of relationships between the yield and the categorical structure. And that gives me some concern. It may be the right thing, but I think the fact that you can do it that way is not necessarily a good motivation for actually doing it that way.
Right. So first the pipeline architecture. I agree that it is not necessarily in itself problematic, right? It depends on.
It's an advantage, I would say.
Okay. Yeah.
That is the thing
Okay.
about LFG. That in fact I would say distinguishes it from HPSG. I think it is an interesting point of discussion separately.
Yeah. Okay. Yeah. So for the others, I think the problem is so with some limited reordering, right? This does require you to put something in a specific position in the C structure where it never surfaces, right? Just to be able to be moved, right? So that I think is the strongest argument. So basically, so if you wanted to do this, for example, or let's just take this example, you need to argue that the phi here, this is initial in S, right? Because you're going to have this rule that moves it over there, right? But there's no evidence that it's there, right? So you open the door to another way of thinking about C structure where its surface position is not a conclusive argument for where it is, right?
But it's very finitely bounded. You can only do these movements with a finite set of vocabulary
Yeah.
items. Whereas the MCFGs are much more powerful in what they can flip around. And so and it's true that from a computation point of view from the safety paper, by the time you've added the machinery of F structure, you can hide a lot of other complexity inside it. But the principles of design of LFG were to try to separate out the recursive machinery of the F structure from a more limited and finitely bounded computation in the phrase structure. And I mean, you may be right. I mean, this is just saying that it's a deeper set of issues.
Oh yeah,
About what formal machinery, and the fact that you haven't extended the formal power of something that's actually pretty powerful. And it's nice, and it's the same argument that we made. But I think the fact that it's restricted to finite formatives is sort of an interesting fact about clitics that was captured in some of these other proposals.
Right. So, but this also, I think, depends on to what extent you can use the machinery for other things in the grammar that you might want to, right? So the idea here that we're exploring but haven't yet made up our mind is that you could use the MCFGs to introduce non-projecting words because they have no particular position in the X-bar theory, right? So that was Togon's observation in her book, right? And so if they're interesting to use for other phenomena like that, then I think that that would be a good argument for using them, right? As opposed to a reversion procedure, which is sort of specifically designed for clitics and will only handle those, right? But at the moment, we don't have other clear examples of where an MCFG could be used, so it's an open question.
So just make one other point of contrast. In a way, what you're doing is hiding that reordering in the C structure computation, as opposed to what we did was to hide it, let's call it, in the kind of morphological string mapping.
Yeah.
So I don't know.
I just got a little question. So some of what you've proposed just reminds a bit of liberation in complex order domains, what people like Joe Penn have then applied also to the question of second position clitics in Server-Crat. Can you comment a bit on that relation of your proposal to liberation in complex order domains, in particular on the question whether you have to liberate all the way down and how much do you have to build that liberation into each and every rule?
Right, yeah, so here on this approach you need to be explicit, right? So you need to have these propagation rules that takes you all the way up. But I think we could do similar stuff so you were thinking about, let's say, clitic climbing, for example, where it goes in a or restructuring the coherent domains in German. Is that yeah, exactly. Okay, there's the relation, but so we haven't worked more on it, so I'm not able to say more on it now. But I think we could use the same mechanisms for that. But it's sorry.
Don't see any questions. So let's thank the speakers.